What if I told you scientists are trying to build a tiny sun on Earth? Not a fake light bulb, not a giant fireball in the sky. I mean using the same basic trick that powers the stars. That trick is called nuclear fusion. Fusion is when two tiny atom-sized pieces, two tiny atomic nuclei, smash together and become one bigger piece. And when they do that, they release a huge burst of energy. That's why the sun shines. It's doing fusion all the time. But here's the weird part. Scientists are not usually trying to fuse random stuff. The easiest fuel to use in experiments is usually a special kind of hydrogen. Actually, two heavy versions of hydrogen called deuterium and tritium. When those fuse, they can make helium and release a lot of energy. So yes, part of the dream is basically take tiny bits of hydrogen and make star-style energy. On-screen captions: special hydrogen fuel, deuterium plus tritium. Helium comes out. Now this sounds easy. Just push them together, right? Nope, these tiny nuclei do not want to get close. They both have positive charge, so they push away from each other, like trying to force two magnets together on the wrong side. That means scientists have to make the fuel unbelievably hot and controlled, so the particles move fast enough to crash together anyway. And when I say hot, I mean so hot that the fuel is no longer a normal gas. It turns into something called plasma. Plasma is like an angry glowing soup of charged particles. You can't just pour that into a metal box because it would wreck the walls. So scientists have to hold it in place very carefully. One big way to do that is with magnets. A machine called a tokamak uses powerful magnetic fields to keep the plasma floating and spinning inside a donut-shaped chamber. The idea is, don't let the super hot stuff touch the walls. Just trap it with invisible magnetic hands. On-screen captions: tokamak, giant magnetic donut. Invisible hands hold the plasma. Another way is using lasers. Instead of holding plasma in a magnetic donut, scientists can blast a tiny fuel pellet with huge laser energy, squeezing it so hard and so fast that fusion can happen for a brief moment. So there are basically different roads to the same dream. Make tiny nuclei fuse and collect the energy. And this is why fusion gets people so excited. If it works at power plant scale, the fuel could be incredibly energy dense. Fusion also doesn't work like a fission chain reaction, and in tokamak-style systems, the reaction stops quickly if the exact conditions disappear. That makes fusion exciting, but not magic and not risk-free. It still needs serious engineering, safety systems, and a lot more work. And this is the most important part. Fusion is not already powering your house. Scientists have made huge progress, including major fusion milestones in laser experiments, and giant projects like ITER in France are designed to prove key parts of fusion at large scale. But commercial fusion electricity is still something researchers are working toward, not something the world has fully deployed yet. So, baby version, fusion is scientists trying to make tiny hydrogen bits hug hard enough to act like a baby sun. That means crazy heat, plasma, magnets, or lasers, and a whole lot of engineering. If they fully crack it, it could change energy forever. If you want more giant science explained in baby language, stick around.